Hi everyone, and thanks for attending this presentation. So today we will make a short demo of how to use the Jinkō platform to calibrate a model. And for the purpose of this demonstration, we will use a pharmacokinetics model of midazolam, which is a molecule used for its sedative properties. So we've already uploaded that model in Jinkō, and we've implemented two modes of administration for this drug, the oral administration and the intravenous administration. For this demo, we'll try to calibrate the oral administration of midazolam. And we know that this oral administration is parameterized by two constituents of the model, which are the bioavailability F and the absorption rate Ka. Now, to help us calibrate our model, we'll use some data from the literature. In this article, we found a graph showing the concentration profile of midazolam in plasma following a 10 milligram oral administration of the drug. So we'll first start by extracting the data from this graph, as well as the uncertainty around each measurement. So we've done that in a table in a CSV file, and we will now upload that data in Jinkō. So to do so, we'll create a new data table item by simply drag and dropping our CSV file. There's a small preview of what it's going to look like in Jinkō. If it's satisfying, I can upload the table. And this is what my data now looks like in Jinkō. Let's now go back to the model to calibrate it. So clicking on the calibrate button here takes me to the calibration interface. I can first attach my data table to the calibration. And it's important to know that doing so will automatically generate the fitness function used for the calibration from the data present in the table. So now I get a small warning saying that the data in the table refers to some protocol arms that are not yet defined. So the next step is to define the protocol arms. So here I'm selecting an already created protocol with two arms. So the first arm, IV, corresponds to the intravenous mode of administration, and the second arm, oral, corresponds to the oral mode of administration. Next step is to define which parameters we'd like to calibrate. So as we said earlier, we're going to calibrate two parameters, which are the bioavailability and the absorption rate. So let's select them both. And we can now set some priors on those parameters. So let's start with the bioavailability. So we know it's a fraction, so it should be between 0 and 1. And we can define an initial guess. Same goes for the absorption rate, except we don't have bounds for the absorption rate. However, we know that its value can span several orders of magnitude, so it might be more convenient to use a logarithmic scale for this parameter. And as well, we can define an initial guess. Now we must also set the duration of simulation. So we have data for something like 12 hours, so we won't simulate for 2 years, but limit ourselves to 12 hours. And we should also specify some options that are specific to the calibration, including the number of iterations that will be run and the size of the population that will be drawn at each iteration. So for the number of iterations, we'll go with 30 iterations. We can always augment that number later if need be. And for the population size, we'll leave the default value, which will be computed based on the number of parameters to calibrate. So we're now ready to launch the calibration. By clicking on the button, we get a small recap of what is going to happen. So which parameters we're going to calibrate, how many iterations, what is the size of the population drawn at each iteration. So it looks good. We can now start the calibration. And it takes us to a new page that allows to both monitor and visualize the results of the calibration. So first of all, at the bottom of the page, we can see a plot that allows to visualize some quantities of interest versus the number of iterations. So here we're seeing the evolution of the fitness function versus the number of iteration. But we can decide to select another quantity of interest. For instance, we might be interested in only the contribution of the oral protocol arm to the fitness function. So we can select it. Then we get a table summarizing each iteration with how long it took, what are some statistics on the fitness function for that particular iteration. And finally, we can plot a quantity of interest versus another quantity of interest. So typically we can plot the fitness function versus the value of a parameter that we're calibrating. So we can select, for instance, f and plot the fitness function versus f. So what does it show? That indeed there is a range of values for f for which the fitness function takes good values. It's even more obvious if we apply an exponential transformation on the y-axis. Now this is for the monitoring part of the calibration. As you can see, we've reached the 30th iteration. There's another tab where we can visualize directly time series for the patients sampled during the calibration process. So those patients appear sorted by the value of their fitness function. So the first patient is the best patient with regards to the fitness function. And we can see the concentration profile for of midazolam in blood for this patient on both the oral administration protocol arm, so in yellow, and the intravenous administration protocol arm in blue. And what's also important to notice is that we can overlay the data from our data table directly on this graph, which gives a visual hint of how our patients fit the data. So obviously for the best patient it's quite good, but if we look at the worst patient, the fit should be quite bad, and indeed it's the case. So now let's go back to our best patient. We can check for this patient what are the values of the calibrated parameters. So here for the bioavailability it's around 0.3, 0.4, and for the absorption rate it's around 40. And if we're happy with those calibrated values, we can directly update our computational model with those values for the parameters bioavailability and absorption rate by simply clicking on that button. So again, a small recap of what is going to change. And if I validate, it takes me directly to the model. And now if I look at the calibrated parameters, I can see that they've indeed been updated with their new values and that they now have a link to the calibration directly embedded in their definitions. Now that's it for our small demo of how to calibrate a model in the Jinkō platform. We hope you liked it and that you're eager to try it out yourselves.